Hello. We are now starting the second part after coffee break. We'll have more two papers related to biology. The first one will be present by Maria de Lourdes Enes Vecius. This is the challenge in assessing color and spatial distribution of bacterial mats in lava cavities. And the next one will be the cluster analysis optimization, present again by Pedro Cardoso. Then we'll have a 30 minutes discussion, and then we'll start the next moment related to education. Please. We have more or less 15 minutes for this talk. Okay, thank you.
During our, actually, I'm not, can everybody hear me? So, Paul, thank you. Oh, I have to because of the recordings. Okay, that's a piece I never like so much. So, repeating, my name is Maria Dapkevicius. I'm here to replace the person that should be making this presentation, Dr. Riquelme, who had to be hospitalized in emergency. So she's stable and doing comparatively well. But anyway, she's not in a good condition to come here and to talk, so I'll be doing her place. We have been working on a project related to microbial biodiversity in Azorian caves already for quite some years. And during this project, we have come across a set of different challenges, one of which we are bringing here to your consideration today in hopes that we may get some input on this important area. Let me first take you on a tour through this, it will be a brief one, through this marvelous world of underground cavities. When you enter a cave as a human, you are immediately struck by what an alien environment you have entered. As the light starts to fade and the air feels cool and moist around you, you are going to use artificial light to illuminate your journey through this rock-dominated environment. And as you progress, you may look around and think that nothing lives here. However, biologists and microbiologists have been discovering a wealth of life in these rock chambers beneath the Earth's surface. Subterranean environments like lava tubes are characterized by a fairly constant temperature and air humidity, and they are oligotrophic environments, that meaning that very little or no organic matter at all enters them through the waters that infiltrate. Although oligotrophic environments may seem places with very little capacity to support life, the reality is that they can harbor enormous biodiversity. The importance of such pristine environments is increasingly emphasized, not only by their role as essential participants in the nutrient cycles, but also because they are a biodiversity refuge where you can find important microbial groups that produce compounds that are useful for humanity. Our studies, as a curiosity, because this is not really a part, well, in a way it is a part of the challenge we are proposing. The compounds we are most interested in are antibiotics, novel antibiotics to replace the ones that cease to function properly due to the appearance of bacterial resistance. So, furthermore, the analysis of the community composition within these caves will help us to further understand the factors that control microbial diversity and community assemblages that can be extended to other habitats and perhaps even to other planets, as some of our latest studies have shown. The biogeographic isolation of the Azores, the huge number of lava tubes we have here, there's more than 300 already, I think, throughout the islands that were explored, make these islands an excellent scenario for studying underground microbial biodiversities. When you look at a cave, you can actually see with the bare eyes some of the microbes that live there. These microbes are visible as stunning, beautiful, white or tan-colored or yellow-colored, large patches, microbial mats, we call them, that vary in relative predominance across the caves and may occur separately, or there may be different colored colonies intermixed in one same mat. Pink colonies, organic oozes, like you see here, and even silica and ferrous deposits, like these ones from Algar de Carvão and these ones from Gruta dos Buracos, are other visible places or locations within caves where bacteria live. The three predominant matte colors that you can see in the Azorean caves, that is the ones I referred when I started showing this slide, the white, the yellow and the tan, as well as the oozes, appear in almost all volcanic cavities and in different areas of the cave. However, other matte colors and other textures are more, such as this one here, these pink hexagons, appear only in one cave and mostly within a single location inside this cave. However, if we talk about the main matte colors, we can really talk about a type of colonization that we will find across different caves. We have, in order to understand the older structure of bacterial communities from Azorean lava tubes, we carried out electron microscopy studies. These studies allowed us to highlight a feature of these colonizations, which is that they are composed by biofilms. Biofilms are cell populations that have irreversibly adhered to a solid biotic or abiotic surface. In the case of the caves, it's of course an abiotic surface, and that are surrounded by an exopolysaccharide matrix that envelopes them. In biofilms, microbial cells live in structured, coordinated, functional communities and are able to thrive more efficiently than the cells would if they would live isolated. The biofilm has this function of ensuring bacteria in a favorable place so that they remain fixed, increase their survivability as a group, and conferring them a higher resistance against adverse conditions. The cave's most visible bacterial growth, so, adopts the form of continual microbial mats. Each one of these yellow patches here is one of those, is a microbial mat, or the form of individual colonies. Small as they may seem, these individual colonies, you can see the scale here to have an idea. Each one of them is a very complex community composed not by one single taxon of bacteria, but by a large number of bacterial phyla, up to 16 or even more. So, molecular identification of the genetic material we sampled directly from the environment by sequencing allowed us to perform molecular studies through the analysis of entire communities of bacteria. This culture-independent method allowed us to reach microbial biodiversity that was previously inaccessible, since it is estimated that you can cultivate in the laboratory only, according to some authors, less than 5%, Others say even less than 1% of the microbes that exist in this kind of environments. So when we did this, we got 16 different phyla. We saw that 16 different phyla were present, and even 4 more groups that are not yet phyla but are candidate groups. The predominant bacteria are, of course, the ones here on the top, and we are speaking about actinos, proteobacteria, acidobacteria, and nitrospirae. These bacteria are very important for mankind, not only because of their environmental importance, but because of their industrial potential. Suffice to say, I think that actinobacteria are the main source of today's antibiotics. So they are a very interesting group, a very, what we call metabolically talented bacteria. Molecular biology studies have highlighted that they have more than 20 different metabolic pathways to produce that may lead to the production of interesting compounds, and some other, like some delta proteobacteria, the myxobacteria, for instance, are also promising in this way. So when we compared the different colors of mats across caves, what we saw is that indeed they present different patterns of phyla abundance, and that may show us that color is a very important factor. Why different colors appear in different places? Why do we have some caves that are totally covered in yellow mats like the one you've seen before? Why some others have intermixed colors? The real truth is we don't yet know, and that's why this color, spatial distribution of color and its quantification is very important in caves. Some studies have been made by a group we work with in the Altamira cave. They reached some conclusions that I'm going to very quickly try to summarize. They hypothesize that the color is linked to the pattern of microenvironment variation in the cave locations. For instance, in Altamira, they saw a predominance of yellow colonies in places where the environmental conditions, microenvironmental conditions, most changed, and whereas the whites were in places where microenvironment was relatively stable, and the gray colonies were in places where the variation in microenvironmental factors was in the middle, in between. So what are the challenges we would like to bring here? As you've seen, color is a very important issue, and microbial and in caves, the color of the colonizations. We didn't yet come up with a good method that would provide us a means to elucidate the spatial distribution of the colored mats in volcanic cavities. That would allow us to separate and quantify the surface covered by each color of mat that we considered. A number of difficulties has been preventing us to reach this objective. For instance, caves can be very complex. They can be much smaller than this room, but they can be extremely large. In the Azores, the largest cave is Gruta das Torres in Pico, which is about 6 kilometers long. Here in Terceira, we have this other system, which you can see is very complex, with lots of interconnected tunnels, and it's more than 3 kilometers long. So it's very challenging to map all this huge amount of surface. Another thing is that visual evaluation of color on itself is very subjective. One proof of this is that, for instance, we have one designation for yellow, but the Japanese have about 200 different designations for colors, much more than we do. So what we call yellow is a fraction of the spectrum, the light spectrum, but for them it might be a different one. And we don't have any Japanese in our team. We do have people from very different nationalities, but not a Japanese. However, we came across different descriptions for the yellow color, just ranging from a lemon type with lots of green yellow to a more golden type with lots of orange. So it's not easy. Furthermore, the walls of the caves are uneven. They are covered by different bacterial mats that intermix. So you can get the lighting conditions are very different. So this can lead to very different luminance, hue, and saturation colors, even if the mats were originally very similar. Furthermore, to complicate even further our problem, microbial mats sometimes juxtapose. I'm not sure whether you can see very well, but here you have intermingling different colors of colonies. So how to account for this when you're trying to measure the extent of surface that is occupied by white or by yellow or by tan? So these are the questions I'd like to bring to your attention. What are the best algorithms for color pattern recognition in uncontrolled environments where angle, lighting, and all other conditions vary widely? And is it possible to perform batch recognition for large numbers of photos, even after calibrating the method with a relatively small training data set? So, to end, I'd like to thank the audience for their attention and the organizing commission for providing us the opportunity to present our challenge in this forum. Thank you very much.
Okay, and for the final talk. Something a bit more mathematical, cluster analysis optimization. The hierarchical classification of sites, species, etc., natural groups. This is common in ecology and related disciplines. In fact, it's something that everyone working in ecology does all the time with more or less automated tools. And there are a number of different algorithms, where the simplest, or one of the simplest, is single linkage, for example, where basically if you have a distance matrix, let's say that in this case, we're talking about species. Species A, of course, in terms of dissimilarity, is the same as itself, so there's zero dissimilarity. It's relatively close to species B. It's farther away from species C, but species B and C are even further away. What single linkage does is first see which of these species is closer. So in this case, it's A and B, and connects them by this level of dissimilarity, 1. And then adds the third species at the minimum distance between it and any of those belonging to the group already formed. Okay? This is single linkage. And then complete linkage, it connects this group with species C by the larger dissimilarity, so 3, and the average linkage by the average of the distances. Of course, this is a very simple example with only 3 species, but if you have 100 species, I'm talking about species, but you can also think about sites. Like if we sample 20 sites in all the island and we want to see which sites are closer, then we can do exactly this same exercise. Each method provides very different results. In this case, it's not that different because it's a very simple example, but when it's more complex, then the results can be drastically different. In general, this average linkage behaves best. How do we say if it behaves as it should or not? One of the ideal method would have a large cophonetic correlation. So if we have an initial dissimilarity matrix and some final matrices, the correlation between the initial and the final should be as high as possible. Okay, there are other ways of looking at this and saying which method is perfect. But as you can see, all these methods that we use today in ecology are completely greedy. This is really simple. This was devised when there were no computers, and we are still using the same methods. In the meanwhile, some consensus algorithms have been proposed, basically to try all possible combinations of multiple methods, to use these three that I've shown, all other methods, and see which parts are common to all the trees, and which parts are discordant, and trying to blend everything into a single tree. It performs usually better than just using a single method. But the fact is, we are still limited by the options given by the different methods. So this is a very difficult NP hard problem. The number of possible dendrograms grows exponentially with the number of entities, because the more entities you have, the more possibilities of combining the different entities you have, and it grows not linearly but exponentially. You must also remind that the length of the branches is a real number, so it can be anything. It's not only the topology of the tree, but also the length of the branches. And there are a number of possibilities that have been sought to solve this, to go a bit beyond these greedy methods, to use evolutionary algorithms, neural networks, self-organizing feature maps, and in fact these have been used in non-hierarchical clustering. But can this be adapted to hierarchical? I guess they can, but fact is nobody has ever done it. So the questions here are: which kind of approach may be attempted to build trees that reflect as close as possible the true differences between site, species, or other entities? And how can we guarantee that the ultrametric distance is as correlated as possible to the original distances, so before and after the clustering? So this is a more mathematical question. Maybe it is relatively easy to solve. We don't know. We still use old methods. And who knows if anyone has the solution right away. Okay, that's it, and thank you. And we now proceed to the discussion, although we are basically out of time, right? But yeah, we are on time. Okay. Ska acender a luz. Okay, so I have no idea if anybody has any ideas, if you like this or not. This is a different way of presenting these kind of problems to a different audience from what we are used to. But anyway, what has driven your attention? Does anyone has any questions and or maybe immediate solutions to the problems. And we had, I must remember, the automatic species identification, the organelle identification, the biodiversity portals, the cave bacterial mats, and the cluster analysis optimization.
Can I start?
Yes, please.
It's the best thing to do with the panel is to start. Then I prefer be waiting starting. I can pick the first talk. It was Pedro Cardoso who just introduced the subject about spiders, about some kind of solutions that you tried and they are available. It strikes me that you said during the presentation that there was no solution to recognize image and to do the same as we do now with text recognition with Google, for example. But it's not true. We can now, from the scientific point of view, and also almost in commercial status, to recognize image as we recognize text, and that could be ahead for your problem. Also, we can use some sort of new techniques and new technologies that Google is using with big data, some parts of statistics, but some parts of data mining, and also neural networks to help the question about classification. Then it seems, then looking to that first talk, then we get in AI some technologies now, and they are available. In my point of view is that 3 or 4 years ago they were not, but now they are in 2013, and we can use that technology. For instance, when we face machine translation 5 years ago, it was not available commercially and in use, and now it is in iPhones, and everybody can do questioning about the things that is interesting for, and by doing the interaction with voice, it can arrive to data. Then the problem with data is the huge amount of data, and with that there is an effort now also in cars that we can arrive to some kind of solution. I don't say that it is the best one, but in AI we use always heuristics to get some kind of solution. And that kind of solution sometimes help to go forward. That's all.
Yeah, in fact, there are already a few systems developed for a limited number of taxa. And this started as far as 15, 20 years ago. But as I said, it's always a limited number of taxa, and I bet that we now have solutions that have not been tried, and that could be interesting to experiment. And if it's possible right now for a phone to recognize text, then I guess it's not. Although it's a different challenge. Probably much more complex. Maybe it's a question of scale. I have no idea. Yeah, we could think about it. So I can get 1,000 images right away to test something.
There is also a recent publication that shows with mammals in the forest that cameras that capture images of large mammals that pass away near the camera, and they are using new technologies to identify those species in a very fast way and compute frequencies of occurrence and things. But is with large animals. I think still with very small teeny things like a bacteria or an insect or a male or a female genitalia is still probably difficult to, but I imagine that the technologies could be easily adapted.
Okay.
Thank you. You were talking about classification of images and stuff like that. I remember that Google, someone in Google Research, has been doing some work on something they call deep learning. Although I don't like the designation very much. The thing is that they try to get millions of images and they try to extract the significant features of those images, and they then use machine learning without training data to classify those images as being something similar. For instance, they've done that with cats, and they fed millions and millions of images into their system, and they came up with something saying that this is the same thing, and all the images were pointing to cats, independently of the, and they didn't have training data, so it was an unsupervised method. You might want to look for something on those terms. Just an idea.
Okay, but in this case, it was all, they had no library, no images.
No, they had
database?
tons of images. The problem was to kind of cluster them according to similarities.
Okay.
And they came up with a method that could do that without training.
Okay.
Without something telling them these are the significant characteristics that make this a cat or another animal or something like that.
Okay. So that's what we would call to classify morphospecies. So
Yeah. Perhaps it can be useful.
One thing that probably could be interesting to recognize is that there is a lobby also in the research in this kind of identification area that is putting all the resources and money to genetic and DNA analysis, and probably we do not have a solution right away available for that, for this kind of image stuff you presented, because there is very few funds going to real research in that area. People prefer to put all the money, like Natural History Museum in London now got millions of euros to create a DNA library for biodiversity. If all the money goes to there, to this kind of research, then probably few people are interested in developing this kind of areas you are putting forward.
yes, in fact, there is a question of what's fashionable now, and right now there is a way to identify well, not to identify species, but to help identifying species, which is basically DNA barcoding. And there is a fraction of the DNA of any living being that can be used to, because it's a very fast mutating fraction of the DNA. It can be used to say which species, which individuals belong to the same species and which individuals belong to another species, so to cluster individuals into different DNA-based species. But and that's very fashionable right now because it's DNA. But it still requires some work, but it's becoming pretty cheap, and there are a number of large projects. But of course, that's only part of the question important. DNA is important, but then the morphology has been a bit forgotten. And well, what we see and with what anyone has access to is what they see, and not really. Not many people have a DNA lab at home, and the fact is that most of taxonomy right now is made by amateurs. We have no access to DNA lab. So yeah, it's two complementary approaches, and unfortunately are almost fighting for resources right now. Anything? No. And there are two related, of course, problems with this image recognition. That is image recognition in caves of bacterial mats, which probably is, well, I don't know, because it's basically pattern. It's basically color recognition. So maybe it's a simpler. There's a simpler solution though. Caves are caves, very difficult environment, and then looking at things inside cells, and that can be another big challenge. So I wonder if this kind of techniques, like the Google techniques or whatever, can be used to this same problems.
I'd like to add one thing, if I may. I think the biggest challenge in caves is not the color recognition by itself, for which you have came up with an algorithm that allows a workable algorithm. The problem here is to account for the irregularity of the surface, because when you photograph something that you think is a square meter, let's say, in order to determine the relative space that each color occupies within that 1 square meter, you may or may not be photographing a real square meter, because the surface has a curvature. The curvature differs in different parts of the caves. Furthermore, you have smooth surfaces that have an area that is closer to the area of the photograph itself, but then you have very irregular non-smooth surfaces with projections and things like that that have, of course, much larger an area. And that is the main problem, how to account for these surface irregularities. And that's the one we haven't quite been able to come up with a solution that all the members of our numerous team would agree with.
Okay, and moving to another subject. Does anyone know how Wolfram Alpha works, really? No? No? I'm surprised. I'm the only one who has an interest in that tool. And the cluster optimization problem. I bet that there are solutions already available. Because we are really dealing still with the same, I don't know, 100-year-old techniques when there were no computers. And in fact, Herman Mendes proposed a few possible solutions. He was the one that already knew some of the possibilities. How, if I can ask you directly, how far are we in this field? Do you think it's really possible to optimize a tree with in a relatively short time in a personal computer? Okay, because in fact there are ways that have been used, for example, for phylogeny. Phylogeny is the grouping, again, the grouping of species into natural groups according to how they evolved. Species evolved from ancestors, and those ancestors evolved from other ancestors. And given DNA data and given morphological data, it's possible to create these trees exactly that say which species evolved from what and which are related, closely related, or that are really further away. But these are really and maybe even these kind of methods. But the data is different. The data is different, and the algorithms probably will have to be adapted in some way, because the goal is different, talking about evolutionary relationships and not about just clustering according to dissimilarity, although those can be somewhat similar. But this is usually done in computer clusters. That takes forever to do analysis when you have large number of entities, and no one has yet come up with a simple, fast solution, because we are basically using this all the time in our laptops. And
yes, it is always an open problem.
Yeah.
It will never be finished, probably. But I think some particular solutions for particular kinds of data, we can adjust, can optimize, can put better algorithms working, yes, of course.
Okay, if no one else has anything to add, then thank you. I hope this was at least useful, that you were able to understand some of our problems as biologists and ecologists. And I guess we are now going to to the next session, education session.
Okay, we'll start now the education session. We'll have first from Universidade de Unisinos in São Paulo, south of Brazil, the professor Patricia, and then we will have the presentation of Professor Rosa Vicari from Universidade Federal do Rio Grande do Sul, from Brazil too. And finally, we will end with Helder Coelho, Professor Helder Coelho, Professor of Universidade de Lisbon University. All these talks will have more or less 20 minutes, and then, as it happened in the previous part of this session, we'll have a small discussion about the subject in here with all the participants. Thank you.
Good morning for everybody. So my name is Patricia Jacques. I'm from Brazil. I work at Unisinos, and I'm going to present this paper, PET Math. It's an intelligent tutoring system for teaching algebra. So this presentation is organized as follows. First of all, I'm going to present some definitions about intelligent tutoring systems. Afterwards, I'm going to talk about our motivation for developing algebra intelligent tutorial systems. Why another intelligent tutorial system for algebra? After I'm going to present our project, our ITS, Path to Math, and I'm going to divide this part of the presentation in the current state of this ITS, the ongoing works, and also the future works that we intend to do. And to conclude, some final considerations. So, what are intelligent tutorial systems? I like very much this definition from Van Leen. Instead of defining intelligent tutorial systems by its components, by its architecture, it's trying to define intelligent tutorial systems by its behavior. So intelligent tutorial systems have two loops. The first loop, the outer loop, it's responsible for selecting a task for the student according to the student's model. So it executes once for each task. And a task is usually a complex problem for the student to solve, but it can also be an explanation for the student to learn. And in the inner loop, the system supports the students when it solves a complex problem step by step. Okay, so it executes once for each step taken by the student in the solution of a task. So another important concept is knowledge. So we can define knowledge as the information that the student possesses and which determines his behavior on a task. If we can suppose that a knowledge can be decomposed, divided in very small units, we are going to call these units as knowledge components or skills. So by now I'm going to talk a lot about skills. So it's a very important difference of intelligent tutorial system from other kind of learning systems, because ITSs are able to detect students' knowledge components. So this is small units of knowledge of the students. So let's talk about our motivation for developing Path to Math. So I'm beginning to talk about my PhD thesis. I developed. It was supervised by Rosa Vicari, the next presentation this morning, and it was an animated pedagogical agent, which the role was motivate the student and increase their self-ability. In order to do this, the agent was able to recognize students' emotions and also to express emotions by its behaviors. Okay, so it had a lot of emotional behaviors in order to try to engage the students and to promote more positive emotions that we know is good for learning. So these agents, these emotional and intelligent agents, was integrated into a not very intelligent learning environment. Let me show you a video. So I'm going to choose one. So in this learning environment, the content was organized in sections. So each section consists of a fixed sequence of web pages that the student should read, learn, and afterwards he should complete a multiple choice quiz. So the big problem that we had is that the environment, this learning environment, was not very intelligent. So we did not have precise information about the student knowledge. It means about student skills, these knowledge components. The only thing that we know, that we knew from this environment, was that students had a good performance on this test in the test for a determined section or not. So when the student did not have a good performance on the quiz, the only thing that the agent could say for the student was, okay, good job, but let's study again the entire chapter, the entire section about time zones, the content that we adapt to this learning environment. And we observed that the student became more frustrated because instead of just learning again this small knowledge unit, this skill that he did not learn, he should study again the entire section, the entire chapter. Okay? So instead of motivate students, as we intend to do, in fact, the environment were frustrate more the students. So we found that it was very important to insert this kind of intelligent, affective agents in intelligent tutorial systems, in intelligent learning systems that are able to provide precise information about the students' knowledge. And why intelligent tutorial system for math? So math is a subject where students fear, and this generates a lot of negative emotions. For example, frustrations, fear of making mistakes, and also low self-confidence. So it makes math a very interesting content in order to insert, in order to study and to adapt to students' emotions. And also algebra, especially algebra in math, is a subject where students have a low success, Brazilian students have a low success rate. So we are developing patch math. So it's an intelligent tutorial system for algebra. It's a web-based system. It means students can access the system anywhere. It's adapted to Brazilian curriculum, and it is constructivist. More specifically, we are using Ausubel theory. It's a kind of cognitive psychology theory of education, and we are specifically interested in students' emotions, how to infer students' emotions, and how to adapt to students' emotions. So let's talk about now, what you have now in patch math, what is its current state. As I told you before, in an intelligent tutorial system, we have the outer loop and the inner loop. So in the outer loop, it's a web-based system. By now, so far, we have a fixed sequence of contents, pages that the sections that the students should follow, and afterward he should complete a list of exercises. So these exercises are equations for the student to solve. In general, each section, each content, each page is a video explanation for the student to watch. Okay. So, and after, these contents are organized in chapters, in sections too. And after watching these videos, he's going to solve equations. And this is the inner loop, okay? So, for the inner loop, we have patch equation. It's a kind of intelligent editor for the students to solve equations. So let's suppose this first line is an equation that the tutor present for the student to solve. Okay. The next line are steps. It means partial solutions provided by the students. This patch equation, this editor, it has an expert system, so it's able to correct in real time any step provided by the students for first and second degree equations. So let's say, so the first one is the equation provided by the tutor. So let's say this was a step provided by the students. The students should select the terms in the equation, in the previous equation. Select, for example, in this case, he selected these two terms, and he selected the operation minus. So he should choose this button minus here, and provide in the next line the solution for this step. And he's going to click in a button here, and the system is going to correct in real time, and he's going to show this sign, okay, when the step is correct, or a sign not okay when the step is not correct. As the system is able to correct equations, he's also able to give hints about any step. So when the student is stuck, he doesn't know anymore what to do, the system can give a hint. He can say, oh, okay, why don't you try to do this operation with these two terms? Okay, and these hints, they are provided in text and also by the animated agent. Besides that, the system can also show for the student how to solve an equation, or the entire equation or a step. As I said before, in order to solve an equation, in order to correct the student's steps, the system has an expert system. We call this expert system as a cognitive model. In this, it's a rule-based expert system, so it has, the knowledge is represented in rules, and rules are in the form if condition is true, then do action, do this algebra operation. In fact, each rules represents a skill we want to students masters. Okay, and this expert systems was implemented with the shell JBoss rules. Here we can see an example of a rule in these expert systems. With the information about these expert systems, we are also able to modeling student knowledge, student skills. So, for example, let's say the system provides this equation for the students, and the student provides this step. What the system is going to do is it's going to try to solve this equation and try to find the same solution that the student provides. And he's going, after applying several rules, he's going to perceive, okay, I used this rule, so for each rule is associated with a knowledge, with an algebra operation. So the expert system is going to realize, okay, so I used this rule related to the operation sum of variables. So it means that the student applying correct this knowledge in order to solve this step. Okay, so it gives information about skills that the students masters for the student modeling. And this kind, and he's going to do this for every step. This kind of student modeling is kind of model tracing. And it's accomplished by this expert system that you call cognitive model, and it's also responsible for giving hints for the students. And as we have rules for the students' misconceptions, it is also able to detect the students' misconceptions. Okay, so here we can see an example of a hint given by the animated pedagogical agent. So this, what I showed you so far is what we have already done in the expert system, is what is already working. So I'm going to talk now about some ongoing works. By now, we just have model tracing. It means we know what knowledge component, what skill the student applying in each operation. But we don't know how much the student masters each skill. For example, for some skill, if the student applied correctly it in the last 3 times, but incorrectly in the first 2 times, what does it mean? It means that the student doesn't know that skill, or he knows. Okay, so for this, we call this kind of student modeling as knowledge tracing. And we are, in this moment, developing dynamic Bayesian network. It's a kind of probabilistic inference in order to detect it. As I told you before, for the selection of tasks, by now we use a fixed sequence of tasks, and we want to select the next tasks based on what you know about the student modeling, and also based on Ausubel theory. This was the old interface. We are also developing a new interface for our environment. In fact, we did a lot of experiments and evaluations with the students. And we observed that the students don't like to choose a button, to have to click in a button here to show which operation. Oh, you are not seeing. Okay, sorry. No. In order to say which operation he is going to use. They think that this is very restricted, and they would like to have more, they would like to be free to solve the equation like they are in pen and pencil. So we are developing this new interface. Here you can say the part of the tutor, the first line, the equation provided by the tutor. The next line are the solutions provided by the students. Okay, so the students are free to provide the solution as he wants. And if he wants to solve in his head the solution and just provide the final solution, he can also do that. He's totally free to do. And here you can see hints and other things of the interface. So this interface was developed in HTML5. So it was not, it's not anymore developed in Java. It means it works, it's very interactive, and it works also in mobile devices, besides desktops. Okay, we are also working with detection of game in the system and using animated pedagogical agents to try to hinder this kind of behavior. Game the system is a kind of behavior that the student try to cheat the system. It means, as I told you before, the system can provide hints for the student while he's solving an equation. And it can ask for several hints for the same step. The first hint is going to be something very generic. Okay, why don't we apply some operation in these 2 terms? And after 5 hints, the tutor is going to provide the solution for the students. And these students are very intelligent, and they quickly realize, okay, if I click 5 times the hint button, the tutor is going to give me the solution. So why am I going to try to solve the equation? This kind of behavior is called gaming the system. And of course, it's not good for student learning. Okay? So you are trying to use animated pedagogical aids that are going to show for the students I'm aware that you are trying to take me. I'm aware that you are trying to get the answer, get the solution, without trying to solve the equation. And we went to study what's going to be the reaction of the student. It's going to hinder this kind of behaviors. And as future works, what we intend to do. So we went to work in the emotional parts of the systems. We went to work in this part of inference of emotions and also in how to engage the students knowing his emotions. So for this, we want to use multimodal inference of emotions. So we also work with inference of emotions by face. It's very interesting because it's more accurate, the inference of emotions. By the other side, we also work with inference of emotions by students' actions using a psychological model of emotions, a praise-based emotional model. And although it's not a very accurate model for inference of emotions, it's very interesting because it explains why students is feeling some emotions. So having these two types of inference of emotions is very interesting for intelligent tutoring systems because we need to know more accurately which emotion the student is feeling, but we also need to know why the student is feeling that emotion. It's because he had a good performance or quiz or another thing. We also want a very good model for expression of emotions for our emotional pedagogical agents. So we are working on extension of the BDI model in order to incorporate emotional mental states. Okay? And the main idea is that the emotions are going to be elicited by these mental states of the agent, desires, goals, and intentions, beliefs. We also work in the expression of emotions by the agent according to its personality. So if the agent is a shy one, he's going to show behaviors that are more shy. And to conclude some final considerations. So PetMath is a project that my group and me, we are developing. So in my university, we just have a master program in computer science. You don't have a PhD program in computer science. So basically, we're developing, the system is being developed by undergraduate and master students. We did a lot of experiments of short duration. It means that students use the system by 1 until 3 hours only. But for the next year, you have 2 partner schools, and we want to do some long-term evaluations. It means the system is going to be used by students during several months, and we want to evaluate the tutor in these situations. So there are so much more to talk about, but we don't have much time. I just want to thank you very much for your attention. And here you have both sides, my personal side and the side of the projects. Thank you.
Morning, my name is Rosa Vicari. I'm from Federal University of Rio Grande do Sul in Brazil. I will present Heráclito. Heráclito is a tutor for logic, and after the Patricia introduction to intelligent tutor, it will be easy to me. It is a cooperate work from my university and Universidade do Vale do Rio dos Sinos, and I think it is a kind of family presentations because after me, Professor Elder will present, and he was my advisor. Okay, then Heráclito is a learning object that the aim is to assist the students in classes of logic for computer science. It consists in a proof editor for natural deduction rules. We have different versions, one for desktop and laptop in Java, and another one for tablets and smartphone using Android operational system. Heráclito is a multi-agent system composed by 3 different agents. The first one is the student profile. It represents the student inside of the tutor system and register information about the student. And the main task is monitor the teaching and learning process, the student teaching and learning process. It was developed according to the proposal of Self and Dillenburg, and then it is composed by 3 different layers: the operational layer, the behavioral layer, and the conceptual layer. It was developed in Java. In the first, the operational level, we have the student model, and this student model checks if the student correct applying the deduction rules. In the second level, the model assesses if the students can be proficient in this reasoning process. In the last one, the student, the conceptual level, the model indicates the concept that were assimilated by the student. And this is achieved when the student understands the implication of the deduction rules in other areas, for example, in logic for computer science or philosophy or something like this. The second agent is the expert, is the tutor agent, and then this agent represents the teacher or the tutor inside the system. And it contains tutor rules for teaching logic. Then this agent follows the student resolution process during solving exercise and has the ability to solve the problem in question. Then the tutor previously knows the problem that the student will be developing. The last one is the mediator agent. It is the core of our system, and it made use of didactic pedagogical strategies in order to assist the students during the resolution process. And it was developed using agent speak. And here an important thing that I forgot. The interface of the expert agent is developed in Java, and the theorem prover developed in Prolog. It is the Heráclito general interface. We have here some introduction about the system, here features, and an login area. Okay, the editor can be operated in two modes, in a single mode without login, but also without pedagogical support. In the second way, when the students are connected with a login, and then the student can receive pedagogical support. Here, for example, in this area, the system presents to the student an argument to be solved, and here we have the inference rules, here the actions that the students can perform in the system. At this moment, he or she are doing this action, introducing hypotheses. These interfaces are in Portuguese. And here we have some presentation about logic operators. And then in this small window, the student introduce his steps for proof the theorem, and here is the idea for feedback, for tutor feedback. So the students are solving the same problem and finish the introductions of hypothesis introduction, and then start to use rules. But in this case, the students are using a correct rule, but not adequate for this kind of problem. And then it's what the feedback inform to the student. If the student select some rule, then the system provide some information about the selected rule. Here, the user finish the solution, and the tutor provides some positive feedback, something like congratulations, it's okay. But the tutor also knows another way to solve the same problem, and then the tutor presents this second way for the student and put some comments about it. It is the interface for mobile, smartphones and tablets, and in the same way, here the students present the solution, the inference rules, and here some operation the student can perform, for example, delete the solution or part of the solution and restart a particular solution, or the student can also ask for help. In this case, the tutor are presenting some feedback about the step 5 and 6, that it's not necessary in this solution. Okay, then the student delete this part, and the system provide another feedback to say, okay, congratulations, you are now back to the right way to solve this problem, and some kind of this. But the student introduce a lot of no adequate steps, and then the systems provide a very hard feedback for the student. And it is now, I will talk about some validation, and then Heraclitus agents were inserted into a learning object composed by a list of 48 natural deductions exercise, and also a list of examples. In the test, the student must perform two parts. The first one, of course, is using the learning object for solving some problems and also study examples. And in the second part, the student must complete an evaluation form. It was given a 20 days period for this experiment. So from a total of 38 students that attending these classes, 23 students solved the exercise and complete the evaluation form, and the students did not have to complete all the list, only what they intend to need. And then, for example, 2 students perform 10 exercise, 5 students perform 8, but 23 students perform all the list. The evaluation form is composed by 25 questions, 10 about pedagogical support, 5 about content quality, 3 about layout, and 7 about usability. We have graphics of all of these questions, but I select only this one. It is about the mediator agent and represents what the students answer for the pedagogical support. Then 69% of the students total agree with the pedagogical support, 23% partial agree, and in this case, they qualify the answer completed something here in this part. Then we have 92% agreement in general about the mediation process. Some conclusions. Based on the student feedback, the mediation process is efficient, and the mediation plays an important key role in the teaching learning process, and we believe that the tutoring system also contribute to better understand the internal process that the students are performing to solve some exercise. And the use of the Heraclitus may contribute to improve the level of the approved students in logic, and the students had no major problems with usability, layout issues. As future work, we intend to develop different things. The first one is in order to improve the student model, and we intend to store all the steps that a particular student are used in this in his or she solution. Then the students can assess it later for thinking about the mistakes, something like this. In the operational way, we want to develop some more compatibility between the user operating systems and the auto-screen, and also we intend to use Heraclitus in e-learning, distance learning. For the tutor model, we intend to develop a lot of things, something to support teachers when they start to select material for their students, or also for introduce new arguments, and create also feedback tool that allows teachers to monitor what happens to the students when they are using the system. A complete description of our work can be found in Artificial Intelligence and Education Journal, and it is my email address. Thank you.
Let me start by saying that I want to cover one of the questions that were stated by the challenge in order to attack the education problem. And the question was about how could we decrease the number of students with failures. And I tried to come back to the classic AI, the good old-fashioned AI, to the 60s, where philosophy was very important. Usually philosophy was a very old discipline. Somehow nowadays is also trying to be important by having connections with neuroscience, with a new subdiscipline called neurophilosophy. And I tried by taking a philosophical point of view to cover the question regarding how can we think about a problem in a way. I'm looking for problem solving. It is an area of application where AI was starting to dig in order to find new techniques like knowledge representation. When we see now AI in 2013, we see that AI is connected not only with cognitive science, but also to complexity science, to neuroscience, and obviously to computing science. Then integration of knowledge, association of disciplines is quite common. Also, when we try to fix the point of view of AI on education, we try to look to the context of the problems we want to attack, and also to think about, from a critical point of view, how can we solve these problems. The question of education is quite interesting because it's an open question, and we get two strong actors, the students and the teachers, and the students are very diverse, and when we think about some student and we compare to another one, we see that they are different. They are different because they learn in different ways. And then starts the problem, how can we help these students with difficulties? Looking to AI also again, we see that now in the applications we get a problem point of view, a user-driven problems, where big data is important now, where we get always an initial state and a final state, where we have also means to travel from the initial state to the final state, and we get solving space and ways to see in a clear way how can we arrive to a solution. Then the problem state is important. The tasks that we associated are important also, and the techniques then we can retire from AI are very important to attack the problems. If we see the side of education, we see that education is about how to process and use information. Then we get the side education, but also the side of instruction. And when we look to the instruction, is mainly based upon communication. We get a combination of basic and pure applied research. We get models that are connected with cognition, and we get some very strong community and also some connections with other communities like data mining crossed with education. Also, we can look to the research that is done nowadays, and we see a crossing between education and AI. Rosa Vicari looked to this, and also Patricia. And also we look to the elements that are associated with technological solutions and tutoring systems as an example. And we find models, we find expertise, we find interfaces, we find domain resources to build up in strong systems. When I started to think about the failure of the students, I remembered that in 2010, Jay Tenenbaum, very old scientist from AI, did a presentation in AAAI about how we could face cancer. That means go inside healthcare, and how could we find new ways to face the problem of the cancer treatment, and he found several characteristics, several attributes of the cancer illness, and also some of these attributes I can find in education. I said that each student is a case. Also, each cancer is a different case with different symptoms, different therapies, different bodies, the people that is ill, and different results. Then I tried also to dig a little bit how he faced the solution of this healthcare problem, and by looking to the classic treatments, and also looking to his own case of treatment. He was also a cancer patient, and he survived with a treatment that he was involved in by using also ideas from AI to solve the problem. Then the lesson we could get from this case study was that by improving the clinic and molecular profiles of patients, that was an idea. Also to construct a huge open source database with all the knowledge that came from solving the illness and the problems of the patients, the response also from the patients to the drugs or the techniques that were applied, and building up a social network, a common social network that was open to doctors and to patients with data from single cases. That means trying to build up a collaborative environment. The lesson that we can derive is that we could face this problem by mixing technology with intelligence. If we now go from cancer to education, we can see that instead of patients, I have students. Instead of physicians, I have teachers. Instead of scientists, I have scientists again. And instead of family, I have the family surrounding the patient. Then what is common, the experience that would get good results, the data, the profiles of the students, and the collaborative environment. That means that we can look into a concrete problem, find some analogies to our problem of education, and see also that in the cancer case study, we had patients that could face his recovery with different speeds, like students in the school. Let's look now to the traditional school. We get an entanglement because we get isolated teachers trying a lone hypothesis with their students in a class too crowded. That is the situation now in Portugal and in the Açores Islands. We get the status with no information of any other experience or identical situations, and also about results. That means no communications, and we get a teacher-centric school. If we want to improve the solution of this problem, we can combine some intelligence to education. We can build up environments with social nets, learning web-based. We could build collaborative environments. We also could get data from the students, build up a kind of patient profile. I call it student profile. And we can go from isolation to distribution, as in the cancer case. Then we can get a new school where education is ability to work, to sync with others. We can get one space where teachers are in connection with colleagues, with students and with parents by using technology. The information over the experience is now available. The results are also available. And we can get also a classroom with active learning, with increased questioning, and obviously we change from a teacher-centric to a student-centric. That means that by combining intelligence and technology, we can arrive to a kind of commons. In the case of cancer was cancer commons. Now I call it a learning commons, where the aim is to face learning difficulties with technology of internet, with techniques of using adaptive trial strategy with social nets, with students controlling the learning process, with the student in the center, and with access to more resources and more data to increase the way how to help these students. Nowadays, we can also see that this kind of experimentation using massive open online courses is very popular, with a lot of universities going in business with this opportunity. And here we get also the kind of each student learning with some own pace, with some kind of resources that are available through internet, and with an open environment to help these new kind of students. Then the challenge are diverse. We can get tutors, we can get more data, we can get recommender systems, simulation-based education software, learning environments, and that means that we can get and use metrics to assess how we are changing the situation and checking if these ways are better than before, but by looking to stability, to skills, to knowledge, to motivation, to direct activity, and that means that we try to open the problem, to see in large, to understand what was behind this specific problem, to get the students in active questioning and in direct way, trying also to solve their problems, looking to the performance, supporting the teachers, and using what is in some educational systems very popular, but not in Portugal, the critical thinking way of analyzing problems, and also getting maps with information, then some kind of pedagogies, kind of therapies that we found in the cancer case study. That's all.
Okay, here we are again for some questions. We are in time, so we are comfortable. We can ask and discuss this subject. The three presentations we have, the first two were more directed to specific systems, as you have noticed. I can start to say that that is an important information. in the afternoon, after the lunch, I think they are already waiting for the lunch because it's time for eat something. We have in the coffee break in the afternoon at 4:30 p.m. we'll have the demonstration in the demo room that is just near the coffee break. We have a demonstration of these two systems, and the people, if you wish, if you want, you can go and see how they work, and the two professors will be there to show you the potentialities of these two systems. Related to these talks, I would like to know if you have some questions. This is a little different from the first part. We had here people from AI that present some solutions for education. As I said in the morning, this is a problem of also using the language and the vocabulary that is very different from education. As you know, the education problems usually are very mainly in the primary and in the other school before college are very. We don't talk to teachers too much, but in AI we have a lot of solutions for problems that exist and then can contribute to solutions and to improve the learning in school. So I first start asking for if everyone in the audience have some question to make to these professors. No? Okay.
Regarding the learning systems, the two very specific learning systems, there's the dimension of kind of how to expose the contents and how to make the students engage in the systems, and then there's the other problems that you mentioned in the first system, for instance, which is the students, if they can game the system, they will, and actually that's common. That's a common trait, not only in learning systems, but also in the game industry, for instance. When you design something with a couple of activities in which someone has to kind of perform a couple of actions, and if there's a flaw which allows someone to achieve its final goal, typically people will use it, and you can assume they will use it. I was considering to ask if you consider gamification as a matter of motivation for the students, instead of kind of trying to encourage them, not really transforming the whole process into a game, but giving them rewards in terms of scores and achievements. Not only that, because that has its value on its own, but making it social. So, because people tend to get very competitive and tend to try to achieve the tasks more frequently and with more kind of they try more if they are kind of competing against each other, and it's kind of a implicit competitivity, not really.
So thank you very much for your questions. So as I said, there are so much things to talk about our project, and yes, it's true. We are thinking about doing gamification, using gamification elements in order to try to motivate the students. I don't know if you perceived in the new interface of patch equation, the new interface in HTML that I present, there was an element in the interface where it was described students' performance. So it's our first try
of doing some kind of gamification, try to show the students his performance. And when we are going to, and a future idea is try to show his performance among other students' performance. So in trying to do this kind of gamification competition among the students. And yes, it's an interesting thing that we can try to do, try to make the students compete game with the systems. And another point that we are also doing is using this kind of animated pedagogical agents. So we think that students try and game the system because they think that the system is full. Oh, he doesn't know that I'm trying to game him, that I'm trying to treat him, I'm trying treating him. It's okay. I only want to have my solution. If the agent show for the students that, okay, I know that you are trying to treat me, I know that you are gaming the system, and I'm not happy with that. So, in fact, we are studying two personalities of agents. One that's going to be angry with the students. Oh, I don't like that. You should not do that. And another one that's going to be nice. Oh, it's not good for you. Why are you trying to game the system? It's not good for your learning. So we already made some stories, and we need to have more experiments with more students to have significant results, but we think this is also a good solution, both of them are good solutions.
I like to see something about it too, because in our opinion, using game strategy is good for young people, but it's not good for adults. We try to use it in health education, using serious games, but the students hate it.
Just telling about what is serious games, I think people know is games that have a context that is real and people play in that real context.
Yes, thank you.
And you say that the students hate this kind of things. What kind of things did you implement that they hate specifically?
Yes. We implement some kind of game using a virtual patient and time to solve some problem about health for this patient. And they answer, and we use also more or less the same content in a traditional way, text, and they answer the form and say, oh, we prefer the text and the traditional way to study this content, and we don't like to use the game. It's virtual patient or this kind of thing.
Oh, I see. The thing is that when I talked about gamification, I was not specifically referring to transforming some kind of process or test into a game. It was more like having the game elements that reward the player or that compare a player to other players. And when I say players, students with other students. And the thing is that, like in game, like what happens in games, that could kind of improve the results or not, but not necessarily transforming the whole process as a game, just the rewards and the achievements of the thing.
Just to continue this interesting conversation, I know another Brazilian group that is working very hard in gamification of intelligent tutoring systems. They are Their names are Sage Isotani and Iggy Bittencourt. They are developing an intelligent tutoring system called Meu Tutor. And it's a kind of web-based systems, and it uses strongly this notion of gamification, competition, scores, and this kind of things. So this is a new trend, a new thing in education. I hope we will have some results soon about it. So you have to do some huge experiments in order to say if it's good or not. But one thing that I'm worrying about gamification is that gamification, it's a kind of extrinsic type of motivation. So we are trying to motivate the students to learn something by extrinsic factors. It means to receive rewards, to be better than colleagues, and this kind of things. And there are some stories that show that extrinsic motivation is not so good as intrinsic motivation. That is, try to motivate the students to learn because the subject is interesting for him, is important for him. So I think that we should try gamification because it's showing very good results in other areas, but we should study this with attention, with special attention for this kind of extrinsic motivation.
That's why I was not so sure about the impacts of gamification in something as like learning. But
Another question, please.
Good morning. Thank you very much for your presentations. I think they were very, very, very interesting to me. Well, I would like to ask Professor Elder if he thinks if the new school paradigm has been applied in Portugal and with which success, and if he thinks that it could be applied to the Azorian system, where we have, so we are told, one of the smaller classes in Portugal, and all the national results show that we are consistently on the bottom part of the evaluations in national exams. Thank you very much.
Okay, I think you just put the point on the school in Portugal in a concrete place. And when we move from traditional school to a new modern one, we get always the problem with the number of students. Like in primary, secondary, or even in university, where we get a very massive way of producing people to be in the market, as we classify the situation now. And the market is now closed, and there is no employment. But the point that I would like to address is how can we face failures with the students that cannot proceed or are unable, sometimes by lack of motivation, sometimes by their social difficulties of the families. There are a lot of explanations for that, and my answer was to use technology, and now I am talking about the situation in Portugal, to open a little bit the way of interaction with those students, trying to cross these students with the teacher, also with other colleagues, and with knowledge or with data that is available in the internet and in specific sites that the student can have and belong to the school. I don't know that this is now common in Portuguese schools or in Azores Islands. But the technology is around us. If it's not common, can be common, because accessing the internet is now common in the secondary schools with students. With the previous government was an improvement of the situation of by distributing computers. Now the computers are more accessible to be bought with lower prices. Then this could be helpful, but as I told you in my presentation, the profiles of the students are important, because I said in the beginning that each student has a learning pace, a rhythm of acquiring knowledge, and those students with difficulties, obviously the pace is very slow, and to improve or to increase the pace to help those students, they must get family behind, they must get colleagues behind, and they must get teachers behind. If the class is too long, the difficulty to the teacher to get too close to the student is obviously more. It's a bigger challenge also to the teacher to get 20 students or 40 students, double. And the double is now, the 40 is now the number that is quite common in the schools. But as a teacher also, I think that the teacher can't go away when he faces difficulties, and he can invent. That's why I used philosophy to open the space of mind or the space of the problem, and to think about ideas to get solutions to the problem. Because when we face, even in the university, then 50% of the students fail, something is wrong, because the opposite is the goal. Every good educational system get more than 90% of success, and if we go to, for instance, Netherlands or United Kingdom, we get an educational system with more success than the Portuguese one. That is not unique in Europe. In Germany, the percentage of failures is very big and is quite astonishing, but is a fact. And how can we decrease that failure? The teacher is responsible. Obviously, the political system that is around the school is also more responsible than the school itself. But we can't say that we just we don't act, we don't try to get an ad for those students, because they are our students. And that is how we can, by getting use or exploring our own intelligence, and natural intelligence, not artificial one, we can combine that intelligence with the technology that is available. And we get every year more technology, and we must learn how to use and explore that technology. And that is quite important to help the students, even in very difficult conditions that are common and known that we get in Portugal.
more questions? Well, I have a question, yes, but this is for all. It seems that technology is already in schools somehow. We have e-learning systems, but they usually are not very collaborative systems. So teachers, most of the teachers, not in university, but in the other levels, usually are not training to use this technology. So I would say that we need also some teacher training. There are other things that are important, I think, and when we start using these kind of systems, we learn a lot of things about how children learn. And this is an example with Patricia, because we start with a system and test the system and then understand what they need. What is the interaction that creates more dynamic in the learning of the children, and if they are children, and in the system per se. I would say that children are motivated to use technology. We know that. So we have a problem here that it's not in the children, because they use technology all the day. And the question is more or less, what is missing? Is this the right system? Is the problem with the researchers in the area? Or is the message passing? Or is it the teacher training? Perhaps all these things are missing for us to change a little bit the schools and using the right technology to improve learning in schools. I don't know if someone wants to comment on that.
So, just a little about our perception in Brazil. Now, we did a lot of evaluations with PET math in schools, and I think that all the questions, for all the questions, the answer is true. So sometimes I perceive that teachers are afraid of technology because students know so much more how to use them in general. Children are get used to use technology every day, and this is not the reality for teachers, at least in Brazil. Okay, so sometimes I perceive that teachers are a bit afraid of using these systems, that children get learn how to use them much quicker than teachers. And this is one aspect, I think. Another aspect is that children use technology every day, and they use very interesting systems with very nice interfaces and very nice forms of interaction. And they also want to use this kind of system to learn. So I think there is a big gap because there are a lot of commercial interesting games, Facebook and other interesting applications with very interactive, that they are very interactive, they have very nice interactive OAs. But intelligent tutoring systems, we develop prototypes, and general, we want to analyze, we want to study some new artificial intelligence technique, and the interface is not so interesting, is not so modern, so friendly as students want to have. So I think this also explains. So it's very important to have designers in our groups and to use gamifications and other things that are going to motivate students also by the interface.
What Patricia told, but in Brazil there is another one. For example, the government provide infrastructure like computers and data show and something for students and professors also. But and they provide training too, but they didn't provide technical support. And then in the first time that something happened with the computer or with the tablet or something like this, or something with the internet connection, then all the technology was put in the side and they didn't more use it. Then it is a big problem in Brazil because it's a bigger country with different support, and it is a problem.
Well, thank you. I'm not from Portugal, so I'm not familiar with the Portuguese education system. But I think in the future, the learning should be more personalized. When you are talking about motivation, then the learning should be personalized to the peoples. So I was curious to see what the steps you have done based on your experience before. In terms of first talent detection, and then based on the detected talents, you provide some personalized learning to students. For instance, it's possible nowadays with the e-learning systems. You should follow 3 steps. First, you should identify the talents of the students, and then first make a direction for them. For instance, I'm interested in the paintings. Some other students may be interested in the computer codings, and some others in other things. But nowadays, in the traditional way of learning, all people should learn the same thing. I just want to know that did you already think to this personalized learning as a future of the learning? Thank
you. I am thinking about it for a long time because we talk about a social education, and in the other way we talk about personal and individual education. And I don't know about the future because it's there is a shock from this different kind of education. It is social or it is personalized. I don't know.
Yeah, so I think I'm only working with intelligent tutoring systems now. So intelligent tutoring systems, they use an expert systems in order to offer this kind of a personalized instruction. So we have personalized instruction for only one subject. But intelligent tutoring systems, they are very specialized. So they are just able to teach one subject, in our case, algebra, or logic, or Portuguese, or other. So just one subject, because they should have these expert systems that are going to try to solve the same problems that students are solving in order to modeling student knowledge and also to personalize learning. But I think that about detecting students' skills, special skills in some subjects, maybe it's possible with MOOCs. I learned, I listened about some cases of professors that are in Brazil that were watching MOOCs courses because they just want to see, oh, how the big professor in Stanford teaches algorithm that I also teach. And of course, they did very well. They had a very good performance because they were also teachers in Brazil. They were also professors in Brazil. And in the end of the course, they were invited by this university, Stanford, MIT, so on. Okay, you have a scholarship with us because you're very good in this subject. So with MOOCs, they are able to detect these talent people, and they also offer scholarships for them.
A comment with your question. You were thinking about MOOCs also, or not?
No, I'm not into these things, you know, I'm just from...
Because with MOOCs they are directed to personals. And usually in my university, a lot of professors, more than students, are learning using MOOCs just to do what a profession must do, be on the right moment and not in a previous knowledge that he learned 10 years ago. Then you want to see how that specific area is now teach, or what kind of improvements at the area. Then for this kind of professional, teacher or not, someone who works as informatics and want to know what's going on with software engineering, with kind of methodology tools and so on, or with agent technology. That is important, for instance, for telecommunications. Someone is programming for a communications company, and that the MOOCs are very good. But when you get massive in a way that is public, with young people that are starting, it's not only the knowledge, the communication, but the education. That's the difference between education and instruct. You can get trained to get better in using that knowledge, but the school is directed to educate the guy not only with some technicality or some technology, but with the space around that. The context and the meaning are also very important. And the role of the school is to educate the population in general, and to give some level to the majority of the people. And after, you can get more things by using a direct connection between yourself and the resources that are available and can be delivered by universities as they are now, not secondary schools. They are universities, as I put in the list. They are delivering courses. Stanford started with AI, with a huge amount of people, and the second one was machine learning. Then two courses, one introduction, the other more specific and directed with perhaps the problem of big data. How can we face now big data? That's very important, as Google discovered with deep learning and all the use of neural nets, statistics, and so on. Then I think there are several sides when we look to these kind of problems, and when I present my paper, I was only interested in success of someone, because when I face a class and I see that I have no success at the end because I get no 100%, that is my goal at the beginning of a course, I'm very sad. Then the first to be in the center is me. I was not able to attain 100%. Why? And then I start to look to the students that couldn't arrive to success. And I try to find in the next course new ways to help those kind of that subset of students that are in trouble at the beginning. But sometimes I get a little bit of improvement and not the big success that I would like. And that is not perhaps my problem, is the system, the education system problem. And then we must find new solutions for that. I think.
Okay, we are in time. I thank you all being here. Now we're going to have lunch, and I will say something about that. The lunch will be, you just have to cross the road, and it's the building at the right, at my right now. Okay, so it's very easy to find. We will have more or less 1 hour for lunch today. The other days we'll have 1 hour and a half. Okay, thank you very much for being this session.